Okay. So section 7.2 is trigonometric integrals. So essentially this is going to be like a substitution rule for trig functions, and it's going to be an easier way to solve for integration when it comes to lots and lots of trig scenarios here when it comes to it. So in this section we're going to find integrals of higher powers of trig functions like cosine and sine, and tangents as well, because we have secants, tangent secants preferably, and a combination of them. The whole section will test your ability to see the problem and try to slowly break it down piece by piece, or and then answer the question itself. Okay, so we're going to go over a couple strategies that help you. But again, it's just lots of patience, because it's mostly trial by error. Unfortunately, a lot of it is trial by error when it comes to integration, as you guys noticed. Going through this class as well. Okay, so here's the major strategy when it comes to sine and cosine. So if we're trying to take an integral of sine or cosine or higher powers or any combination of sine and cosine in our integral. Okay, the first one is if the power of cosine is odd, then we'll use the property cosine squared equals 1 minus sine squared, which is Pythagoras theorem, right? To write the integral. So in other words, we're going to substitute cosine squared to make it look like this. Okay, so in the integral. And then we're always going to be letting u equals sine x in our substitution rule. Okay, that's the first one. The second one is if the power of sine is odd, so if it's just the opposite, right? Then we'll use the property of sine squared equals 1 minus cosine squared, which again is Pythagoras identity, and write the integral. And then we're going to substitute u equals cosine for our substitution rule. Okay. So again, then you're going to figure out if the power. So we're going to look at the powers, see if one's odd, one's even, and stuff like that. Okay. So the next one is if both powers of sine and cosine are actually odd. Okay, so like 5 and 5, 3 and 3, so forth, right? Then either of the ones above will work, okay, which is a good thing. So we just pick and choose one or the other. The fourth property is that if the powers of both sine and cosine are even, okay, then we'll use a half angle identities, and we're going to use one of these identities to help ourselves out. And this is what the problem is. Sometimes one doesn't work, and you have to go back and figure out which one actually works out to help you out when it comes to it. So it's not always going to be a straight boom, do one or the other. It's going to do it. So you have to be very careful which one you use. And that's when sometimes you have to go back and redo it, and just have a little bit of patience when it comes to it. Okay? So those are sines and cosines. And the next rule talks about the tangent and secants. Okay? So these are some strategies, again, to integrate to the form tangents and secants into higher powers. Okay? So if the power of secant is even, then we'll use the property of secant squared equals 1 plus tangent squared, which is, the other Pythagorean identity for tangent secant. And then we'll use tangent x as our substitution rule. Okay? And the last one is if the power of tangent is odd, then we'll use the property of tangent squared equals secant squared minus 1, which is the other, Pythagorean property. And then we'll use u equals secant to use our substitution. So notice it's just figuring out which scenario we're in and just following that template itself. Okay. So for example, let's try example 1 so you can see what these powers are going to look like. Okay. So first one says find the integral of sine to the fourth cosine to the third power, right, dx. All right, so we want to figure out which of these situations are we actually in. Okay. So we can kind of rule out 3 and 4 because they're both not odd. 3 and 4 are not odd, and they're both not even, right? So it's either going to be 1 and 2. And notice, right, sine is an even power, so since cosine is odd, which is 3, right? So therefore, we're going to use property 1 to help ourselves out. Okay. So what we're going to do is going to rewrite this. So the integral of sine to the fourth x, and then we're going to do cosine x times cosine squared x, and that's why using this property there. So we're just going to break it up. It's looking like that. So now, once we broke it up, we'll use our operation here. So we sine to the fourth x cosine x times, now substitution, 1 minus sine squared x. So that's how we use these strategies. So you just use the equalities we have to do that. And now at this point, we're just going to bring in sine. So we're just going to bring this in and leave cosine on the outside. So the integral of cosine x, and in parentheses, sine to the fourth x, And here gives you minus sine to the 6x dx. Okay. Now you see, okay, all we did was manipulate it when, it doesn't look any nicer when it comes to it. But again, right, we use a second type. We're not really done with the property. It says now we're going to let u equal sine. Because remember, the whole point of this is just using the u substitution method. So we're going to let u equal sine of x. So the du, right, the derivative, is going to be cosine of x. And notice, aha, now it makes it much easier because that's exactly, according to the substitution method, works out. There's your cosine, your dx. So now if I rewrite this integral, this is now going to become the integral of u to the 4th minus u to the 6th du, which is way easier to integrate, right? Okay, so taking the integral, this is u to the 5th over 5 minus u to the 6th over 6. Oh, no evaluation, right? So this should be plus c. So press that and just plug in what u was to begin with. So our integral is going to be sine to the 5th x over 5 minus sine to the 6th x over 6 plus c. And that is how we integrate using this type of properties. Okay. So let's try some more practice problems so you guys can see how this would actually work out. All right, second example. So we want to find the integral of tan to the 4th secant to the 4th. Okay. All right, so if we go back to our scenarios, right, here's our strategy for tangent and secant. So we only have two here. It's either the secant is even or tangent is odd. It's one or the other. So in this case, we have secant is an even, right, even power. So therefore, we're going to be using this strategy. So we're going to break off secant squared and then plug this into it. And then at the end, we're going to have our substitution be equal u equal tangents. Okay, so let's see how this would work out. Okay, so I'm just going to rewrite this. Like that. Okay, and now I'm going to substitute instead of secant squared to 1 plus tangent squared. So now this ends up being integral of tangent to the 4th times 1 plus tangent squared squared, like that. Now, maybe we're okay, that kind of makes sense, but what's going on here, right? Because at this point, we want a tangent to be, we're going to let u equal tangent. So if we do that, well, the derivative of tangent is secant squared x, but that's not here. Uh-oh. What do we do now? So this is what I mean by sometimes your first approach isn't, going to be the answer, right, when it comes to it. So, which means we gotta go back and figure out what do we do wrong, or what's another way to rewrite this. So instead of just being secant squared squared, I'm going to rewrite this as, so I'm just going to go up here. So this was no, that doesn't work. So the integral of tan to the 4th x secant squared x times another secant squared x, just like that. Okay. So now when I use the substitution, so this didn't work out, so I'm just cross this off. So when I use this portion now, it's going to be the integral of tan to the 4th x secant squared x times 1 plus tangent squared x.